Awesome. I think we can go ahead and get started here. To everyone that is attending, thank you so much for registering and joining this webinar where we're going to talk a bit about the impact of artificial intelligence on enterprise network infrastructure. Quite timely since everyone is talking about AI kind of nonstop these days, fortunately or unfortunately. And obviously, my name is Dennis. I'm CEO and founder at Lightyear, and we have our wonderful co-host Ali from Graphiant here that I'll introduce in a moment. But before we get started, just wanted to remind everyone here that this webinar is recorded and you'll get the recording within 24 hours sent to you via email. If you want to rewatch any portions, take notes or anything like that, throughout the presentation, there's a Q&A feature within Zoom that you can utilize to submit questions. We'll aim to get to those questions, maybe leaving a little bit of time throughout the presentation and or at the end. So please do submit questions. The more questions we get asked, the more engaging the presentation will be for everyone here. And at the end, we'll be sending out a feedback form. And if you have any feedback on the presentation, we would love to get it from you because it'll help us put out more useful content for all of you in the future. So once again, thank you for joining us here. And quickly, just to introduce myself, my name is Dennis. I'm the CEO and co-founder of Lightyear, which many of you who may be attending are familiar with. Today, we're an enterprise software product with over 300 customers that's raised about 30 million in venture capital. Prior to that, I was a hedge fund investor at a company called Point State Capital, which is a $10 billion hedge fund, and previously worked at Goldman Sachs doing investment banking. And I'm here with the wonderful Ali. Ali, would you want to introduce yourself briefly?
Thanks, Dennis. So Ali Sheikh, I head up product for Graphiant, a networking company based out of the Bay Area. We have been at it from 2020. We got started in the middle of the pandemic, so it's been a fun time to see the evolution from a COVID era to an AI era, ignoring the blockchain era in between that hit us for a year or so. Before that, I've been building large-scale network infrastructure with Cisco and with Viptela, the first SD-WAN company, started all the way back in 2012 and then acquired in 2017. So if you're the money guy, Dennis, I'm the engineer here.
Hopefully we're both more than just the money guy and the engineer, but I'm fine with that characterization. And, I also have to say that, Lightyear does a bunch of work with Graphiant. The Graphiant product is awesome, and they've been one of our favorite partners to work with. So excited to be doing this together. Let's get into it. So in terms of the agenda, it is maybe worth reviewing, like, why is everyone talking about AI in the first place? What happened? Like, AI has been a topic for a long time. We'll talk about the state of AI in the enterprise and what's being seen on the ground just in general. Then we'll start to get into network infrastructure and talk about the physical enterprise WAN as well as the cloud and how they interplay with one another, and then utilizing AI in the context of networks. And then we'll also talk about utilizing AI in your network procurement. Obviously, that's to some degree where Lightyear comes into play. Talk a little bit about that. And we'll talk about building an AI optimized network edge, which is very much where Graphiant comes into play. So let's get started. Why is AI so hot right now, and why is everyone talking about this nonstop? It's actually worth just recollecting what's played out in the past few years that's led to Wave. So a lot of what people are talking about in artificial intelligence are neural networks that basically, these are like mathematical models that are aiming to simulate what goes on in a human brain and can learn things over time and undergo actions based on that learning. And that's basically, to some degree, what people are talking about when they're talking about artificial intelligence. And neural networks have actually been around for many, many decades. I think the first neural network was invented in the 1940s. They've just gotten a lot better with more technology and better mathematical models. But in recent history, even before all this current AI hype you see, neural networks do a lot of things around language modeling and speech recognition really well. For example, Siri on the iPhone is a long-standing neural network powered product. There have been lots of powerful neural network products around text generation and many other things that you've had machines do before this AI hype wave. AI has been around and present and been doing things for you in your daily life as a consumer, and pretty exciting. But there have been a few things in the past several years that have led to a significant change or sea shift in AI that's led to the hype you see today. Um, there's a new type of neural network called a transformer model that was invented within Google, and it's an architecture that basically improved significantly the ability for an AI model to perform natural language tasks requiring long-range contextual understanding. So basically creating the structure by which you could create the GPT models in particular that you can almost talk to kind of like a human. That type of model infrastructure or model structure didn't exist previously and was invented within Google. After that, the OpenAI team, which is like a nonprofit that I think was founded in 2015, they invented a form of transformer models called GPT, which is called like the generative pre-trained transformer models that are really, really large and trained on lots and lots and lots and lots of parameters, which they've iterated on with some very smart PhD scientists, and then created GPT-2 and GPT-3, improving model parameters by orders of magnitude. I think GPT-2 was trained on something like 100 million parameters. GPT-3 was trained on something like 1.5 billion parameters, and they're going up by orders of exponents. In 2022, this is where a lot of people really started talking about AI, no matter who you are. OpenAI released a consumer version of the GPT model in chatbot form called ChatGPT, based on the GPT 3.5 version of their model that took the world by storm. And it reached 100 million users in just 2 months and created this global craze of generative AI where students are now using ChatGPT to write their essays and avoid doing homework. And everyone has to think about AI. And you can sort of see on the right, putting into perspective how insane it is to have reached 100 million users in 2 months. And basically, since 2022, these transformer models have continued to get a lot better. The GPT models have gotten better, and there are all these other companies building forms of transformer models that are competitive with the GPT models, and they're good at very specific things. And a lot of venture capital has been invested in the space. I think there's been close to $50 billion of investment in AI startups just in 2023 alone. And there's this whole fundamental thought that AI is going to transform work. And we are here talking today about AI. I'd be curious, Ali, I'd love to get your perspective on being sort of a venture-backed founder during all of this playing out. Any perspectives or observations that you think are worth noting?
The biggest transformation, I think, is what we're going to see now is when this first came out, right? I mean, those who have been in this space have been at it for a long time, but the barrier to entry changed. It is now so easily accessible to common users, people who don't necessarily have expertise or knowledge about how these things are built, but they can access it and benefit from it. And so now we're entering the stage where infrastructure and applications that leverage this are going to become more pervasive. So that really, I don't necessarily consider it pure hype. I think now we're at a stage where enough fundamentals have been built that now we're going to see infrastructure evolution for it, and then new applications and new use cases. So this is definitely a time of transformation. I am one of those believers in the camp that this is something that will transform everything that we do.
I think that's a really good way to put it. The interesting comp, I think, is the emergence of the iPhone and the app marketplace around the mobile phone or the smartphone emergence, where in year one of iPhone, like the cool things were like, oh my God, I can download a notes app and a to-do list app. And those are sort of the easiest, most native use cases that people thought through. It takes some time to figure out, okay, clearly this is a powerful technology everyone's using. What do we do with it and what's actually valuable? Then a few years later, you get things like Uber, which fundamentally change what you think you can do with a smartphone. And I think we're on the early precipice of that type of transition occurring here. And I think, you put it really well. That's a good way to look at it. And on that note, I think that's a good transition to the state of AI in the enterprise in Q3 2024, where the enterprise has gone through sort of like a mini period of hype and infatuation, and now more so like hitting reality and value creation with AI. Um, you know, this is just based on reports that I've read that really survey CIOs, CEOs, and CTOs on utilization of AI. You know, the simplest way to put it is I would say if 2023 was the year when generative AI was hot and there was an infatuation phase, 2024 is when it really began to enter the enterprise in some form or another. Based on a McKinsey survey, something like 65% of enterprises are utilizing AI regularly in some capacity. And early on, enterprises noted that the tooling came out and people just started using it in a variety of ways, good or bad, and took a little bit of a spaghetti on wall approach to trying things to determine what would work, what wouldn't work. But now enterprises are not just blindly buying and rolling out products, they're being a bit more controlled and thought through and are laser focused on applications of AI that are value created, use cases that clearly benefit the enterprise on either the revenue generation or cost optimization side, rather than just doing AI things because AI is popular. Um, Enterprises have faced a lot of issues building trust with the new AI tooling in particular. So with these large language models, you can feel as if you're talking to a human and things are text-based, but also they hallucinate a lot. They take a bit of a probabilistic perspective to responses given, meaning based on an input, you can get multiple different types of responses based on what's asked, and getting accurate answers can be difficult at times. And at an enterprise, depending on what it is you do, you may not be able to tolerate, for example, 90-95% accuracy, depending on the use case. That's been an issue. And then also changing workflows. Rolling out a lot of this tooling has resulted in enterprises asking employees that have been doing things a certain way for a long time to change how they're doing things, changing habits, and maybe even augmenting headcount if it's based on trying to utilize AI in the context of workflows. The most common use cases seen today are things where like these models are built for natural language processing and generation. That is the thing that they are best at today based on the way they're structured. So the use cases most commonly leveraged in the enterprise are things that revolve around that: creating content, personalized marketing, design development, in an IT context, an IT help desk chatbot or assistant, and a variety of products in that areas. And I know, Ali, you've definitely observed via your enterprise customer base and maybe even internally or elsewhere via anecdote that lots of employees are at enterprise today are utilizing AI in known and also many times unknown environments, which can create lots of concerns.
And that's very true in terms of the way that's being adopted. If you look at the first wave of it, it's a very consumer style model. People just go onto a website, start using it, generate images, generate some text. I can imagine most people in this webinar right now, and people who are going to watch the recording, they're probably using ChatGPT in some shape or form to write email responses when they want it to sound formal and don't want to have to think about it. It's fairly common. But from an infrastructure standpoint and on the enterprise side, that poses a material risk. How much of proprietary sensitive data is being put out of the enterprise into a chat interaction? That's a very serious risk concern around how people are using this. And so very quickly it became a risk mitigation effort. But the long pull of why the CEOs, the CIOs aren't just looking at it from a negative view of just a security risk. They're looking at how this will transform the data they already possess. What new use cases will emerge? And so investment in infrastructure around this is scaling up rapidly. When you think about the implication of what this means is when you were describing the transformer journey, we trained it on internet data. We trained it on publicly accessible data. But that's a percentage of the total data we actually have. Enterprises hoard and protect their private data quite rigorously. Their infrastructure is tightly controlled. They maintain their perimeters. That data has not been shared with the AI in any shape or form. The applications that will be built on that data will be net new. And so what I see in the enterprise sector is, yes, people are using this for email and images. The security folks are concerned about what might be leaking out, but the real investment, the real focus is optimistic and positive around we need to build net new infrastructure to enable these new applications we're trying to build, new experiences, new offerings for which we need wholesale new infrastructure. So the buying cycles, the things that people are looking to procure, it's very different. The conversations are rapidly changing around all of these different verticals in the company. We need new infrastructure for it.
That's actually a really good segue into our next topic, and fully agree with the points noted. You know, the last observational note on this point before we move on, which kind of ties to what Ali, you just walked through, is that the chart on the bottom of this page, you can see this is sort of like the distribution by organization of quote unquote regular utilization of AI within the enterprise. And, you know, I was noting like marketing and sales and product and or service development. These are the areas where you can really see just utilizing a GPT model or something other being beneficial, and potentially net new, you know, you can generate text, generate content, help me write copy for this product, things like that. Maybe no harm there. But you know, the third segment here, which ties to a lot of the people watching this webinar, is IT, where you're probably dealing with a lot of sensitive and internal information where security may be concerned, what's disclosed may be a concern. And to the note of sort of like new infrastructure and new applications, new experiences, you know, the thing is you may not want to directly share with Microsoft or whoever owns your you know, the specific underlying AI being utilized, all your internal IT constraints or issues or something or other. So you know, that's where you start to get into territory that you want to be thinking from first principles about like where information is going. Is it being utilized to train models? Is it going somewhere where I don't want them to know what someone is typing into a chatbot or something? These are very important concerns that you have to think through from multiple levels. But on that note, you know, like Ali noted, to utilize AI to the fullest, depending on the way in which you are utilizing it. And by the way, this is a great area where if you have any questions, like absolutely please submit them. The enterprise network is changing quite a bit, especially, and this differs sector by sector and use case by use case, but there are a few common threads that at least we've seen from the angles of Lightyear and Graphiant. As a reminder, you know, like Lightyear helps enterprises with network procurement. So we see what enterprises are buying and why. And these are some common threads that have been observed. With some breadth at this point. So, you know, we can go through one by one, and this is where we talk about the enterprise physical WAN. But first and foremost, when you're utilizing AI tooling at the enterprise, which is quite different than the consumer uses of these things, you may go through self-hosting of your own models, whether they be open source or closed source, and also training of models. And the things there, you know, you may have to basically input and output lots and lots of data all the time. And also you may have very GPU heavy, compute heavy servers. So you may be going through basically you may be building out compute intensive data centers.
This is definitely, Dennis, we see a lot of this. So what we see a lot of this, and people will see like it's a natural flow that people are doing this through. AI workloads consume a lot of compute, right? The GPU intensive workloads are very heavy. Power and sustainability is a big driver. Where do I place this workload? How can I deploy this compute? So we currently, I think, and we actually have engagements ourselves. The way it works out is people will say, Graphiant, we're looking to build out a whole bunch of data centers and we need network for it. And a lot of the times we'll bring in Lightyear and say, scope out where you're going to deploy this. Which facilities are you going into? How much compute do you need? And it naturally progresses to each of the points that we'll talk through. But this is very real. I see so much investment going into ginormous amounts of compute being deployed all over the world just for this.
And that is exactly what we see as well, from the end of Graphian. And I'm sure this demand is also coming from your end users in different ways. We also see this demand from our end users too. And that sort of ties to the next two pieces. So basically, you have these more compute intensive data centers that may be hosting and or training models. And then from there, the things are, well, you have a lot of ingress and egress of data, which may mean that you probably want higher bandwidth on your WAN links. So if you're getting point to points or IP transit or wave circuits, we're generally seeing higher bandwidth tiers getting purchased than we have historically for AI specific use cases. And also, like, the next two points tied together, the location of this computation matters, because latency also matters given the amount of data going in and out and how important this compute is becoming. So enterprises will end up more strategically placing their data center nodes, whether they be sort of like on-prem or in a colo space or something or other, but more strategically placing nodes. So you end up with more WAN nodes, like more of a distributed computation model is the kind of thing we're seeing more often with higher bandwidth and things strategically placed to optimize for latency considerations. And we see that more and more based if the enterprise is really rolling out AI specific use cases. I don't know, Ali, if that ties to what you've observed as well.
It definitely is the case. I think while AI is software and we think about software, the physical elements of the world we live in matter. Where is the energy? Where is the power? What is the distance between two locations is quite significant now, because now we're not talking about human beings interacting with data and applications. We're talking about machines and data interacting with other machines and other data. They're very latency sensitive. That affects them in ways that it doesn't affect us. We can wait a couple of seconds. If this video glitches out a little bit, we're going to be okay. But the application itself reacts quite badly. They start throwing alerts, all kinds of problems happen. When you talk about real-time machinery and they have to make local decisions very quickly, it means they're processing data, analyzing, and reacting to it in real time. So bandwidth, latency sensitivity, and compute positioning is quite significant. That's leading to people when we design networks to say, are we designing the topologies, the networks, in the most efficient way possible based on these constraints, rather than the classical models we've had in the 90s and the 2000s? Because what we were then servicing were still human consumers of data. We are no longer dealing with human consumers of data. We're talking about autonomous vehicles, self-driving tractors, drones, all kinds of things that need a ton of capacity and SLAs on the network that they intend to use.
That's exactly right. And even directly tied to that. So those are, now you're talking about the physical world WAN, things within your control. And there are many more nodes in the network transmitting data. And then latency really matters for some of these use cases, like, drones, self-driving cars, where latency really, really matters. You're going to end up with more WAN nodes. Then the other thing is, given your cloud architecture, we're at first talking about like self-hosted data centers and things of that nature. But second, if you're operating cloud infrastructure, and a lot of enterprises are in sort of like a hybrid or multi-cloud environment, utilizing some of the public cloud vendors for this stuff, you may be paying for dedicated connectivity to a specific cloud at high bandwidth. For example, getting a 10 gig or a 100 gig direct route to Azure or AWS or something or other. Like that's a thing that we see more commonly. And then, the final point here is with all this, you have more WAN nodes, more WAN links, a more complex WAN overall, and just a lot more to manage. What you want out of your WAN goes up, just like the amount of demand there. And that's where you get into WAN orchestration software. And the importance of WAN orchestration software goes up quite a bit. And that's also exactly where Graphian plays.
It does. And if we think about the people who are looking at the future of their network infrastructure, if you're in the enterprise, you're going to have to think about you need a lot more compute for these workloads you're going to deploy. You need a lot of capacity because you're transferring a lot of really sensitive data. You want latency SLAs. You want to make sure that your network provides guarantees on where this is going. You're going to use the cloud. That's an inevitability. You're going to use Amazon or Azure or Google. You're using something. And you have to manage all of this. You have to keep in mind all of the regulations, the policies, the risk concerns to deliver the services to the business. So all of this you have to do. And from our point of view, we see this as a big driving force of the next wave of infrastructure. And I see this, the question in the middle, right? It's in the increase of power, how can we alleviate costs? And that's going to be such an important piece when you design this infrastructure. You're going to use more power. And so your cost mitigation comes from, am I using it in the most efficient way possible? Trying to put all of your stuff in US East in Ashburn, Virginia is not going to work. There's limited power there. So if you look at deploying potentially in, I don't know, Wisconsin, in Montana, suddenly you're rethinking, okay, if I'm getting cheaper power there, do I have the network infrastructure that will support me? It goes back to your compute intensive data center will dictate where you get bandwidth, where you get latency, cloud connectivity, and how you manage all of it.
Awesome. Well stated. And that's where we can move to the cloud architecture section of this. So overall, the easiest sort of the easiest consequence when you look at AI is just enterprises are spending more on cloud. AI is very data and compute intensive, and AI tools can be costly to utilize today, even though the cost curves are improving over time. So there's just more cloud infrastructure spending overall for the enterprise. And for some of these AI applications or AI software applications powered by sort of like some sort of like underlying large language model, some of the spend numbers and margin numbers are pretty insane because this stuff is expensive to do. Underlying that are just pricier servers. AI optimization requires very high capacity, GPU heavy servers that have higher average price tags. I'm sure everyone here may have seen the cost of some of the NVIDIA GPUs and where they are today, and also some of the supply chain constraints on that. We'll see whether or not that persists, but servers are costly to roll out, and it's tough to get the hardware at the moment. That piece may alleviate a little bit over time. Any observations to that end, Ali?
I think it's, if you look at everything that's being done here, right, is people are trying to find the best way possible to build the new applications that they need to. Power, energy, cost are huge factors, and optimizing for it is constant. And I think you'll see what this represented. You have a lot of options in terms of how you build what you need to build. But what is being built is what's interesting. And I think we're going to talk about in just a second the use cases that are being tackled. But again, as you're looking at the network that you have to build to support where your workload is, it's pretty much everywhere. I mean, this slide essentially tells you, you could be anywhere, you probably are. This workload could be everywhere, it probably is. And so that complicates the network that you have to manage and the results that have to deliver for you. I think this leads into the more exciting piece, Dennis, is probably the next one, right? Is what do we see that's being built? Like that always excites me. Like there's means to deliver, but what is it that we're building? What are we seeing?
Yeah, absolutely. Let's talk about that. And real quick, also just to cover a couple of the other points on here before heading there. The one quick through line that I think is worth covering is basically change in overall cloud architecture. Enterprises historically, you may have seen them being a little bit more monolithic with their cloud architecture, utilizing maybe sort of one of the large public cloud vendors. You're now seeing much more hybrid or private cloud infrastructure or multi-cloud infrastructure to make use of these tools. Um, Azure is gaining a ton of share overall, and that you can actually see in sort of their earnings numbers. And that they've already had quite a bit of a toehold in the enterprise, and now that's strengthening a bit. And there are these new AI specific hyperscalers, like a couple of companies, I'm familiar with are Lambda and Foundry that are basically trying to build AWS for AI specifically. And there are a number of these sprouting up that are taking share. So the cloud game is as complicated as it's ever been to that end.
And you're right. And I think it's you see it globally manifesting as well, right? We see government re-looking how they do infrastructure investment in a totally different way. You look at the creation of companies like G42 in the UAE, where there's sovereign attempts to build artificial intelligence in country with specific infrastructure built on regulation. We know the world is a strange place with the geopolitics that happen all around us, but that is leading into a real serious awareness at government levels around where is the data? How is the data being used? And are we building infrastructure with national security in mind? I think the United States always has the luxury of being the leader in many, many ways because we innovate here in a whole other way. But I think everyone else realized this is almost like a reset moment. It's anyone's to win the AI race. You see that investment in China, in the UAE, in Saudi Arabia, in Europe, everywhere. I think we're going to be talking GDP levels of investment because of how serious this is for national security.
And on the next page, we can just talk about utilizing AI in the context of your network operations. So there are a variety of applications getting built today to try to do things that leverage AI to better operate your network. And we can quickly touch on a number of the use cases that people talk about and what is more real and what is maybe less real today. We have this sort of like spectrum built out here, but I think all of these things will be to some degree pretty real in the reasonably near future. But on the top, you start off with areas that are more real, basically troubleshooting and issue resolution. AI can have access to what is going on in your network and can tie basically an issue that you can basically prompt a chatbot or something or other with, and maybe tie that successfully to the root cause, providing insights to IT team and hopefully saving you some time. And along with that also, like maybe a notch less real, but somewhat real is like AI analyzing your actual network operations tasks and traffic patterns to help you get better performance by automating routine tasks and or suggesting things to you.
And those things, I think, Dennis, you'll see, right? We've seen a lot of that already being brought into market. So those are where a lot of people have already built automations and bots. I mean, we do that, you do that. Lots of other companies have been looking at how do we augment our existing teams, simplify certain tasks that were just time consuming, make it really fast and efficient. And so we've taken what we used to use automation for and then just brought in AI and just made it that much faster for ourselves. The real evolution, though, I think is still a little ways away. And I think this is where enhanced security, the predictiveness of how to deal with networks and actually have really smart assistants, that I think is a little ways away. It goes back to what you'd highlighted at the beginning. We still haven't solved the problem of, can we fully rely on what the AI is saying? Is it being 100% truthful? And is it doing exactly what is right for us? That is still debatable right now. It can make up stuff. It can mess up a lot of things. It can buy stuff it shouldn't have bought. It can deploy infrastructure in ways it shouldn't have. Guardrails still need to be built so that it does things the right way. But I think the evolution of where we're headed is going to be, how do we become more predictive? How do we proactively build and solve things and then have those intelligent assistants. Right now, the bots that we're going to have, they're kind of interactive in terms of, hey, can you tell me about X? But what they aren't ready for is, we're just going to go proactively buy a bunch of data center space, deploy a bunch of network, and deploy a bunch of workloads proactively, because we know in 6 months you're going to need it. They're not there yet. So the evolution is going to happen fairly quickly. And I think this is the trend we're going to see. It'll solve problems for us now that are painful, but easier to solve. Where we're headed is going to be almost like they're going to be our business assistant. They're just going to go figure out what we need, what we might need in 6 months, and get the stuff ready for it. So I'm really excited. I think what this represents is a whole new way of thinking about infrastructure. This is the time to build out infrastructure, procure, invest, because the world as we know it is up for transformation in a way that hasn't been seen since the dawn of the internet, is how I feel about it.
Yeah, and the interesting thing here is you can also really visualize the progression based on the spectrum of what's noted on this slide in particular. The top two leading to the bottom two, with regard to just how much better the models are getting. And that's where trying to roll out tooling that can benefit you in this manner becomes ideally more important than ever to some degree, um, in the context of just arming your team with what's best available. And that's what gets to, just in terms of like closing out here, we can talk a little bit about sort of how Lightyear and Graphiant play into these items. So
I'm curious because I use a bunch of Lightyear stuff. So I'm always excited, Dennis, when you tell me, what are you guys doing new? What have you got going on? Because I'm not just a partner of yours. I use Lightyear infrastructure. So tell me, what are you doing?
So yeah, everyone knows this, but basically business telecom is not really built around the buyer. Workflows are really manual. There's very limited transparency into how to make decisions, the best possible decision, vendor performance, ideal pricing. That becomes more difficult in an AI world. And also, when you're growing your network, it becomes really hard to track and manage your services, which becomes very costly for the enterprise. And that's why we've created Lightyear. And Lightyear is a software product that we call the telecom operating system. And we have the most powerful data set in the industry that effectively utilizes automation and AI in a couple of different ways to digitize and automate the full lifecycle for all of your telecom services, built around continuous and systematic cost optimization. And that comes with a few different components that I'll go through in a second. But really, the through line that's important to note is that you'll spend 70% less time on telecom procurement and vendor management and save 20% or more on the cost side when leveraging Lightyear. We have procurement software that basically digitizes your entire RFP process. If you're going to add to your network, and it'll automate an exhaustive vendor search. We can provide you with network engineering support. You can manage installs and lots of other components of your network at scale. And we have this network inventory manager that basically gives you a full comprehensive view into your network, automating a variety of things for you, like tracking your renewals, placing tickets on your services, basically visualizing all of your expenses, and a ton of other things so that you can manage the entire life cycle. And in recent times, we've added a bunch of the products. So our network inventory manager, we've taken a step forward in helping visualize data to help you move forward as an enterprise user. So we will actually proactively utilize our data set to present you with opportunities to optimize your network with it based on all the data within your network. And those opportunities get better as time passes and the more data you have within Lightyear. And we'd love to demo this for you with this new network inventory dashboard that we've added. And finally, in a similar vein, we've recently launched a bill consolidation product where basically you can get one simple consolidated bill for all of your telecom vendors and services. We'll actually proactively, on an automated basis, audit all your vendor payments and billing every single month to make sure that things are paid both on time and also that you're paying the right price. And you add this to the network inventory manager and procurement service that we offer, and you can basically automate the management of your entire telecom network, which, in the vein of what's going on with AI, just becomes a bit more important. And can hand off quickly, Ali, for you to talk a bit about Graphiant, because I know
Yeah.
you're tackling this from a different angle here.
So I tackle it very differently. Once I have done my procurement through Lightyear, I get a bunch of contracts, I get a bunch of locations built out for my end customers. I deploy the software that builds the network infrastructure. So if you go to the next slide, Dennis, what really we focus on is this world that we're going to live in, this network that has to accelerate and deliver AI use cases. One, it has to be fast. I don't have to redesign the whole network every time. I need this network to be programmable on demand. So once this infrastructure is built out, this software needs to take care of all of the flow of traffic. Why? Because that comes to the second piece. You need assurance. You need to know the path that the data moved on. You need to know what SLAs you got for that data as it goes between workloads, between users, between applications. Control over your data is paramount, and being able to make sure that a network you have delivers that is part of our software stack. Because where this world is headed, is you're going to find new ways to monetize this data. You're going to find new ways to drive revenue, deliver new services, and your network that enables these AI use cases cannot be the obstacle. It needs to be built fast, operate autonomously, deliver data guarantees and SLAs so you can monetize the data. So if you go to the next slide, Dennis, what Graphiant delivers is we deliver a network as a service, already built so you don't have to build it. It reduces the noise that will come from a system because there's so much data moving. The things that matter to you should be very clear. This is your data in flight. This is where things are good. This is where things are bad. And this is where things might need to change. And so anytime you need to buy and deploy new services, you're not having to find an army of engineers to redesign your whole network. It happens fast, it happens quick. And this is, again, not just a sales pitch here. This is true for how we build it. My workflow tends to be, I need to figure out a new city I need to operationalize new services in. I go to Lightyear and I figure out what's available in that city. Like, all right, these are all the things that exist. But then my software enables once I buy it. I'm not figuring out or hiring 100 people to figure that out. My network is operational. It builds itself. It sets up the protocols, sets up the data flows, and I just make buying decisions. So ultimately, the future, the service that Graphiant offers is around your network should be a service. It should be simple to operate and gives you business insight so that you can deliver new services with ease. So that way, for those who are interested, right, those are all things you're going to have questions on. Reach out, get a demo, see how it works, see how it gets built. And that's what I'll tell you.
Awesome. Thank you, Ali, for that overview. And, just in terms of closing here, thank you everyone for watching the presentation. Hopefully you learned a thing or two. You will get a recording email from us within 24 hours that'll have the recording of this presentation so you could rewatch if there are any specific points. And there is a post survey where if you have additional questions or something that you felt was unanswered, you could, of course, leave us a question in there. And we'll also have instructions to where if you're interested in getting in touch about something AI related, something about the presentation, or about either of our products that you can get in touch. But of course, you can find us at graphian.com for Graphian and Lightyear.ai for Lightyear. Thank you so much, and it was awesome presenting here.
Thanks for having me, Dennis.
Thank you, Ali.